Now that we're able to find the derivative of a function, now we can start examining functions, and one of the things that we'll be doing is finding the highest and lowest values on a graph, which is actually called absolute extrema. So at the end of this lesson, you'll be able to find the absolute extrema of a function on a certain interval. Right, first of all, what exactly is an absolute extrema? Absolute just means it's the highest or the lowest, and extrema is just a peak value or a valley value. The minimum value of a function is going to be called the absolute minimum. And the maximum value on an interval is called the, surprise, absolute maximum. Okay, and what we're going to be doing is actually dealing with an interval. We'll be looking for what is the highest y value that we're going to reach and what is the lowest value that the function will reach. And again, I'm just going to put this in parentheses to remind us that these are actually y values. The extreme value theorem states is if f is continuous on a closed interval ab, then f has both a minimum and a maximum on the interval. So if we stop the graph at certain points, as long as the graph is continuous, it has to have a highest value and it has to have a lowest value. So let's go ahead and look at some examples. You'll notice we'll be locating the absolute extrema. Extrema is just more than one of the function over the indicated intervals. So you'll notice on number 7, it is a continuous graph. My interval is going to go from x equals 1 to x equals 4. So sometimes I find it helpful to draw boundaries for this. So we're looking at this little part right here. That's the part of the graph we're looking at, and actually that's all the graph there is for this one. Now what I'm going to be doing for this is if I'm going to find the absolute extrema, my absolute minimum is just going to be the lowest that y ever goes on this interval. You'll notice the lowest that y ever goes is y equals 1. Okay, and my absolute max is going to be my highest y value in that interval, which I notice is 1, 2, 3, 4. There we go. Okay. My next example, this time my interval is -2 to 2, and again notice my graph stops at -2 and 2, so that's kind of convenient. But again, I'm just going to darken in the interval that I'm talking about. Okay, so now if I look on this specific interval, what's the lowest value of y that my function ever gets to? And you'll notice that's a y value of 0. So my absolute minimum is going to be 0. And then for my absolute max, I'm just going to look at what is the highest y value that I ever get to, and that is 2. So my absolute max is equal to 2. All right, example number 9, you'll notice again I'm given a graph. It's a continuous graph, and my interval goes from -2 to 2. Notice my graph actually goes on and on forever, so there really is no formally highest and lowest, but there is on the interval from -2 to 2. So I'm just going to cut this graph off. So notice if we cut it off, we don't even have the arrows in it anymore. So this is the part of the graph I'm talking about. So if I'm looking for an absolute min, I'm looking for what is the lowest y that is ever reached in this part of the picture, and that is down at -2. And then my absolute max is what is the highest y value that this function reaches in this section, and that is +2. Okay, you'll notice that when I'm dealing with absolute extrema, notice that the absolute min and max on this one, they both occurred at the endpoints of the interval. You'll notice that the absolute minimum on this one happened at the endpoints, and the maximum actually happened at that peak value. And we learned from before that that was actually where the derivative equals 0, so it actually happened at a critical number. And you'll notice on this one, our absolute min happened at x equals negative, or absolute min was -2. It occurred at one of our critical numbers, and the absolute max of 2 actually occurred at one of our critical numbers, because remember, critical numbers was where our derivative equaled 0. So absolute extrema can occur. It can either occur at an endpoint of an interval, or it can occur at the critical numbers of the interval. So if I want to find the absolute extrema and I don't have a picture to look at, we're just going totally non-calculator here. What we're going to do is actually find the critical numbers, because those are actually places where there could be an absolute max or absolute min. And then we'll actually evaluate the function, because we need to find the y values, because that's what extrema are, they're y values. And then we'll actually evaluate f at the endpoints too, because those would also be possible candidates. The least of the values will be our minimum, the greatest will be our maximum. So let's go ahead and do some examples to make that make sense. Okay, so the example is to find the absolute extrema of the function on the given interval. We have x squared times x squared minus 2 on the interval from -4 to 4. So we want to find the highest and the lowest that this graph goes. The first thing that we would like to do on this one is actually find the critical numbers, because those could be places that there could be a high value or a low value. And again, I'm going to, before I take the derivative, I'm going to actually work this out. This would be x to the 4th minus 2x squared. Okay, now I'm going to go ahead and take the derivative. So I'll get 4x cubed minus 4x. Again, I would like to find the critical number of this. So to find the critical number, I need to find either where the derivative equals 0 or where it's undefined. In this case, we'll just find where it equals 0. And when I do that, I'll factor out of 4x. I'll get x squared minus 1. And then once again, I can factor x plus 1, x minus 1. My critical numbers will be x equals 0, x equals -1, and x equals 1. So that's places where it can happen, but we need to find out what are the values there. So we'll actually plug these into the original function. So I'm actually going to find f of 0, I'm going to find f of -1, and I'm going to find f of 1. Okay. I also, though, have to test my endpoints. So I also have to find out what is the y value at -4 and what is the y value at 4. Okay, so now you'll notice I've just got lots of work ahead of me trying to find these values. I'm going to, I think, go into the one that I actually worked out. So if I plug 0 in here, I will get 0. If I plug -1 in here, I'll end up getting 1 minus 2, which would be -1. If I plug 1 in, I'll end up getting 1 minus 2, which is again -1. If I plug in -4, okay, if I plug -4 into my calculator for that one and plug it in for my x value, I'm going to get a value of 224. And then if I plug 4 in for my x value, I also will get a value of 224. So the question was to find the absolute extrema. So my absolute minimum, the smallest y value that my function ever reached was -1, and I got that from either one of these places. That was the smallest y value. And then my absolute max was positive 224, because that was the highest, the biggest y value that I ended up getting. Notice that the min actually happened at one of the critical numbers and the max happened at the endpoints. So either one of those would be candidates for that. Alrighty, let's try the next one. Again, we're looking to find the absolute minimum and absolute maximum. So the first thing that I want to do is find the critical numbers. The first thing that I'm going to do to take the, before I take the derivative, is rewrite this. This would be x squared minus 4 to the -1. I do notice that there are parentheses, so I'm actually going to change that to u. So I'll have u to the -1. So now when I go to take the derivative, I'll get -1 u to the -2, and then times, don't forget your chocolate, the derivative of the inside would be 2x. And now I'm just going to rewrite this. -1 times 2x would be -2x, and then the u ends up back on the bottom. And then if I rewrite that one more time, putting my u back in, I'll get x squared minus 4 squared. All right, now to get critical numbers, we want to first of all look, where would that derivative equal 0? Well, the derivative would equal 0 when the numerator equals 0. And so my critical number for that part would be x equals 0. A critical number also occurs where the derivative is undefined. So I also want to look in the denominator, where would x squared minus 4 squared equal 0? First thing that I'm going to do is square root both sides to get rid of that square. So I'm really just having x squared minus 4 equals 0. And then I'm going to factor this into x plus 2 times x minus 2. And then my x values for this one would be -2 and 2. So I actually have 3 critical numbers. I have x equals 0, x equals -2, and x equals 2. So those are just x values, but to find an absolute minimum or absolute maximum, we need y values. So I'm actually going to be finding what is g of 0, what is g of -2, what is g of 2, and then I'm also going to be testing the endpoints, because absolutes can happen there too. So we also need to find g of -1 and g of 4. And then from here, this kind of just becomes a working out pain. So I'm going to show you on your calculator how you can actually find those values, and I will allow you to use your calculator to find these values. So I'm going to flip over to my calculator right now, so you can go ahead and grab yours out too. What I'm going to be doing is just typing in the original function, which was 1 divided by there we go, x squared minus 4. And then what we can do in this one, I don't need to graph it, I'm actually going to go to the table features. There we go. All right, now I can just enter the x values that I want to enter. So I know one of them, just thinking off the top of my head here, I believe one of them was 0. And then we had -2, and then we had 2, and then we had -1, and we had 4. So if we look at our values, we've got -0.25, I've got errors at -2 and 2, and then at -1 I have -1/3 it looks like, and at 4 we have 0.0833, which we could figure out that is a fraction if we wanted to. So now let's go back to the other screen, and when I found 0, I believe it was -0.25 when we did that. G of -2 and G of 2 actually both ended up being errors because actually the function is undefined at those points. So we're just going to cross those off. And then when we plugged in -1, we got -1/3. And then when we plugged in 4, we got -0.083, I believe. Okay, one other thing that I'm going to say about this one right here, x equals -2, we could have crossed off in the first place because -2 was not in this interval, so we wouldn't even include it as a candidate. So anyway, now from here, we need to get an absolute min. Okay, my absolute min is going to be the smallest y value, and I believe that's going to be the -1/3 because that's the largest negative number there. And then my absolute max will be my highest y value, and that actually is going to be the -0.083. So notice in this case, actually, the absolute mins and max both occurred at the endpoints, but we wouldn't know that unless we tested everything. So hopefully now you can find the absolute extrema of a function on an indicated interval.